We're going to start taking a look today at some notes on regression. You will need a calculator to follow along with what I'm doing, so make sure you have that handy. So first off, we see some data, and for this data, we have inserted the function that fits the data best. So I want you to take just a moment, and I want you to label which of these, pause the video and label which function fits the data the best. So here's what you should end up having for each one of these, the data that would fit, or the graph that would fit the data the best. And we know that for most of these situations, they're not going to have a domain of all real numbers. For example, this is the height of a pendulum swing, and the swing number is not going to have a domain of all real. So we're just looking for that little piece of the data we have which would fit it best. And notice that for these, every single point is on the function. That doesn't happen very often in the real world, and so we end up in the real world getting something like this. So the best we can do is draw in the graph or the model of best fit and then make a prediction about what's happening. That's the best we can do. So we can find a regression equation. So go ahead and turn the page and grab your calculator. So we see here that we have some data, and the data is representing the number of tickets received with the number of accidents for a group of 5 men. So for example, one ticket, a guy that received 5 tickets had 2 accidents. A guy that received 2 tickets had 3 accidents. So we're going to put this into our calculator, and we're going to see what happens. But first, go ahead and take a moment and draw this scatter plot. All right, so notice that I've drawn this scatter plot. It has 5 data points on it. And so my x-axis, I'm going to represent tickets, and my y-axis, I'm going to represent accidents. And so I'm going to find the equation of best fit. And so actually it tells me, if you read on down, we're going to find the linear model. So here's what we're going to do, and you can follow the directions here on your calculator. We're going to go to y equals first and just hit clear. And then we're going to go to second, y equals, and we're going to choose to turn your stat plot. We're going to hit enter, and we're going to turn it on. And so that will enable us to graph data. Now, if you're graphing something other than data, you need to go back in and hit second, y equals, and you need to turn that off. So if you get an error message when you're trying to graph something, that may be why you might have your stat plot turned off. All right, so let's insert our data. Okay, so I'm going to go back up here at the top. These are where the instructions are here. So I'm going to go to Stat and hit Enter on Edit. And notice you should have an L1 and an L2. If you do not, you can hit Stat and do Setup Editor. And that will enable your L1 and L2, okay? Anytime that L1 or L2 is missing. So in L1, I'm going to put my X's. And in L2, I'm going to put my Y's. So now that I've turned my stat plot on, I've already turned my stat plot on, I'm going to hit zoom. And if you go down through here, the only one that makes sense is 9, zoom statistics. And so there we can see our scatter plot. Okay. And so now I'm going to find my regression, my line of best fit. And so I'm going to go back to Stat, over to Calculate. And if you look, and again, this stuff's all on your notes here. If you look, I'm going to go down to LinReg, which is number 4, linear regression. Mine says L1, L2 already. If you have an older calculator, you don't need to worry about doing anything. Leave everything else blank. Just hit Calculate. And so you can see that we have found the line of best fit. A is our slope, B is our y-intercept, so y equals 1.2x plus 0.4. So then we've got some questions here. It says, predict the number of accidents If someone receives 6 speeding tickets, well, you're just going to take the function that we found and you're going to plug 6 in for that. And so that's very easy to do because you do have a calculator here. So it appears, I didn't type that in correctly. It appears that someone would get 7.6 speeding tickets. And here's what I would say. No, you can't get 0.6 of a ticket, but this is a prediction anyway. So if you were in a statistics class, it would be perfectly fine for you to report 7.6 as an answer because it's an estimate. So your estimate is somewhere between 7 and 8. Would this appear to be increasing or decreasing? Well, it's definitely increasing because we see that our slope is positive. And then let's find the average rate of change. Now notice, I'm going to read this carefully. It says, find the average rate of change for the table. So I'm going to go back to my table, and when x is 3, y is 3. And when x is 5, y is 7. So if I'm finding the average rate of change, I find it just like I do slope. 7 minus 3, 5 minus 3, so I get 4 over 2, so in other words, 2. And so the units would be 2 accidents, because that's our numerator, per ticket. Okay, let's turn the page. So this time we're going to be looking at a different set of data. It doesn't give us context for this data. That's fine. So let's input it. I'm going to go to Stat, Edit, and I can I want you to pay attention here. I can either hit Clear or Enter, or I can actually clear every separate data point. Hit Clear and Enter. I'm going to give you a warning. Do not hit Delete. That actually will delete a list, which would mean you'd need to go to Stat, Setup Editor to get your list back. Okay, so again, I've gone to Stat, Edit, and I'm going to input my data. Okay, if I have something in Y, I want to clear that. I'm going to make sure, and it will be turned on after I've turned it on once, but I can see that my stat plot is turned on, and I'm going to hit Zoom, and I'm going to hit Zoom Statistics, which is number 9. And so we can clearly see that this is a quadratic. And I'm going to save myself a little bit of time. I'm not going to graph this right now. So how do I find the quadratic model that would fit this data the best? So I'm going to go to Stat, over to Calculate, and if you look down our list here, we see number 5 is a quadratic model. And there it gives us the equation. So y equals 2.091, and I'm rounding to 3 decimal places, x squared, plus 0.333x, plus 3.061. And it says make a prediction of y when x is 5. So I'm going to, or negative 5. I'm going to plug negative 5 into the equation I've written here. And you have a calculator to do that. So that doesn't take very long to do. And I noticed I typed 5 in here, but I'm squaring it, so that really won't matter. I did put negative 5 in. So I'm getting 53.671. Does it appear to be increasing or decreasing? Well, if I look at my data, it appears to be doing some of both. On part of my function, it is decreasing. The data is tending downward. And then on the other part, it's tending upward. Remember, you always talk about increasing and decreasing from left to right. Start on the left, go on the right. That's why I put my pencil over here and went across. Find the average rate of change using the data in the table. So for -1, my y value is 6. For +2, my y value is 10. And to find the average rate of change then, change in y over change in x. So 10 minus 6 over 2 minus -1 gives me 4 over 3. Okay, one more type of regression that we're going to take a look at, and then you can answer some questions here. So we see that there's some context to this data. X is number of years since 1980. Y is the per capita bottled water consumption. So once again, I'm going to go to input my data. I'm going to go to Stat, Calc. I'm going to clear my list. And then I'm just going to type X's in Y1 and Y's in L2. By the way, I am pausing the video some and typing things in, so if you need to pause so you can get caught up with me, you can, because I'm pausing the video on my side. So I've got my data in. I already have turned my stat plot on, so that means I'll just need to do zoom 9. So as I look at this data, it looks pretty exponential to me. And it does tell us here to find the exponential regression. I'm going to skip graphing this by hand. So I'm going to go to Stat, Calculate, and if you look down your list, you got to kind of move your cursor here. You will find 0 is exponential regression. Just hit Calculate. So my equation then is y equals 2.593 times 1.106 to the x. So that's my exponential regression. Okay. The next problem says to find the consumption in gallons for the year 1992. Now I'm not going to plug 1992 in. Go back and look at your table. The x values represent the years since 1980. So if I want to find for 1992, I'm going to plug 12 in because that's 12 years from 1980. So again, I'm just going to take my calculator and I am going to round it somewhat. And I'm just plugging 12 in. And so I've gotten 8.687. And by the way, 12 would be in here, and 8.687 does make sense with the rest of my data. Let's go look at our graph. Increasing or decreasing. So as I move from the left to the right, if you're riding a roller coaster, your data there is going up. So this is increasing. And it says predict the average rate of change, and it does say using the table. So I see 0 to 2.4, and at 10 my y value is 8. So the average rate of change is found the same way that finding slope is found. And so when I type that into my calculator, I get an average rate of change of 0.56, and the units would be gallons per year. Gallons per year. All right, so then you have some questions for you to go answer on your data. You can rewatch the video if you need to see the calculator steps again, and you guys have a great day.